Hello friends. So in this lecture, we'll continue with the same RC circuits. So one element of R, and one is C. Okay, so the excitation here is also current. In the previous video, we discussed the current excitation, and we've seen the step current, and after that pulse, and after that a repeated signal or the square wave. Okay, so here there is a little modification. There is a current step we are giving here. Okay, so the modification here is that instead of the R in the series with the capacitor, now we are seeing that the capacitor and resistor are in parallel. Okay, so the problem statement again is to plot the V out and IC. Okay, so first we'll analyze as it is what is given there, and after that we'll do some modifications. Whether we'll take the means simple version of the circuit like a Thevenin equivalent or Norton equivalent, and after that we will proceed. Okay. So as of now, I am considering whatever is given. We'll proceed in that way only. Okay. So what is happening here? At t equal to zero negative, my In is what? In is nothing but zero. In is 0. Okay, so I'm considering the circuit is open. The circuit is open means there is a no source is applied. We can consider. So the only circuit we have is R and C, and we are considering that there is no initial charge. So we can consider the VC 0 negative is 0 volt because of no initial charge. Okay. So now at t equal to 0, we are applying this step current. So I can say at t equal to 0 positive, my IN is what? IN is what? 5 ampere. Okay. So what is exactly the scenario for the circuit at t equal to 0 positive? We know that we are applying a step current, which is the signal of very high frequency. So I can consider that this is my IN, which is equal to 5 ampere at t equal to 0 positive. So this resistor is as it is, and I will consider the capacitor to be shorted. Okay, capacitor is shorted. So what is the V out here? VC 0 positive that we are seeing here is 0 volt. Or as there is no initial charge, so we can consider that it will hold its capacitor will hold its value, which is nothing but a 0 only. Okay, so this path has low impedance. So what my input current will see? Okay, here when the input current coming at this node, it is seeing two paths. One is this IR and one is the IC. Okay, so as we are seeing the impedance, the cap is 0 here, that I can consider XC. The magnitude is 0 here. Okay, so the all current will flow through this low impedance path, which is nothing but IC at 0 positive comes to be complete IN, which is nothing but 5 ampere. 5 ampere. So it simply means in there at that time my IR 0 positive is your 0 ampere. Okay. So initially the resistor is not taking any current because capacitor is shorted. When capacitor is shorted, the all current is passing through the capacitor only. Okay. So this is the discussion till this point. Okay. Now what will happen? As my constant current is reaching the capacitor, it simply means the capacitor will start charging. Okay, so what will happen for t greater than 0? I consider some instant of the time, whatever it can be. I should say it is nothing but 0 plus some t naught. Okay, and this t naught is very small. Just after that, I mean to say 0 time, I want to see what is the status of my circuit. Okay, so if capacitor is having the charge or can say the current of 5 ampere, so what can be the like a slope? Okay, slope of capacitor voltage for t greater than 0, just at an instant, or I should say t positive only, I can say it as slope at t equal to 0 plus what it is. It is nothing but the all current is flowing across it. So this is the slope. But what do you think? This is the current is going to remain same as it was in the previous question? No. In the previous lecture, we were seeing that a constant current was flowing through the capacitor forever. So the slope was 5 by C forever after the t equal to 0. But here what is happening, as this current is passing through the capacitor, it is charging the capacitor. Let's say the capacitor has some voltage value built at this instant. Let's say at this instant t equal to t naught, for the VC is built by 1 volt. Okay, so if 1 volt is built across the capacitor, then what will be the capacitor current and what will be the resistor current, we have to see. When the capacitor voltage is 1 volt, this simply means the capacitor voltage is applied across this resistor, so IR will build. So I would say IR at T naught will be what? 1 by R. Okay, so whatever the current that was coming from the input is now going 1 by R to this resistor, and left is going through this capacitor. Okay, so this capacitor current will be what? 5 minus 1 by R. Okay, so it is less value. Let for the time being, if I consider my resistor to be, here I am considering the resistor to be 1 ohm, and let's say my capacitor is to be 1 farad, and what it can be, the IC T0 will be what? T0 or just T0 plus, whatever the instant we can consider. It is nothing but 5 minus 1 by R is nothing but 4 ampere. Okay. So what is the slope of capacitor voltage around this time instant is nothing but, is it right? 4 ampere per farad. What it was here, it was 5 by C means 5 ampere per farad. Okay, as my capacitor is also 1 farad, I have considered. Need not to consider the capacitor value. Okay, if I consider it as a cap only, then it is 4 by C. Previously it was 5 by C. So what we can see at time instant t naught, when my capacitor is charged to, I mean to say 1 volt, then my resistor is also having some current, which is IR, has some finite value of the current. So with that amount of the current, now the capacitor has some less current, because the amount of the current passing through the capacitor is nothing but a input current minus the amount of the current across the capacitor is what? Input current, which is a constant value, minus IR. Okay. So the IN is constant value is 5 and IR is increasing with the time. As IR is increasing with the time, IC is reducing with the time. Okay. So for initial, what we have seen at t equal to 0 positive, IC was 5 ampere. At t equal to T0 positive IC was what? 5 minus 1 by R, where 1 is nothing but I assumed that capacitor is charged to 1 volt. That's why it is 5 minus 1 for R to be 1. It is nothing but 4 ampere. Now let's say at some different time instant, this guy is the T1, my capacitor is charged to 2 volt. And what will be the current across the capacitor at around that instant will be what? If R is 1, and it will be 3 ampere. Okay, same we can consider a few more instants of the time. There my capacitor value to be this, so I'm considering that my capacitor is slowly charging to the value 1 2 3 volt, then it is remained as 2 ampere. So as my current is decreasing across the capacitor, so I can say here as my current across the cap is reducing, it means slope of charging is also reducing. Okay, slope of charging is also reducing. So simply my capacitor is charging in the exponential fashion only, because at every instant of time, so if I say this is my VC, which is also called V out, and if I mark few instants, it is T naught, 0, T1, T2, and so on. So at every instant the slope is reducing. So overall it is looking as a nothing but a exponential nature. Okay, so what is the final value of the capacitor voltage? So more like with a smooth end, it should be some sort of exponential. Okay, this is my VC or V out. Okay. So we have seen this capacitor current is reducing at every time instant. It is reducing. So it is from 5 by r, it has to reach to 0 value. Okay. It is 5 by r initially to 0 value here. Okay. So now point comes, what is the final value of the voltage? So what we do for the final value? We consider that capacitor is slowly charged to some steady state value, so that the entire the current is passing through what I mean to say resistor. So as the resistor current is increasing slowly at some instant, okay, IR is increasing because capacitor has some voltage which is increasing continuously when it is charging. So IR is increasing. It simply means slowly what will happen. IC is nothing but IN minus IR. As IR is increasing, so IC is reducing. It means it will reach to zero at some point of time. So when it will reach to zero, what will happen? What is the scenario of the circuit around that point? So this is your 5 ampere. So when entire current of the 5 ampere is flowing through the resistor, which is nothing but the 1 ohm here in this case. Okay, so it is, I have considered 1 ohm, but you can consider R only. So okay, so in a steady state we will consider that capacitor is open is a 1 point. Okay, capacitor is open is a 1 point. So capacitor open simply means capacitor current is reaching to zero. Okay, capacitor current reaching to zero means all I in means 5 ampere is passing through this. So what is the voltage VC or V out in the steady state or a time long after this t equal to 0 is infinite is equal to nothing but 5 I in times R. If R is 1 here, then it is a 5 volt. Okay, so simply we can see what is this? VC 0 positive was your 0 volt. VC infinite is nothing but I in times R, which is comes to be what I mean to say 5 here, and R is your 1, so it is 5 volt. So it can be now like 5R. Okay, so here it is 5 volt, it is 5 volt. Okay, so what we can see, the slope here is different at every coming instant, the slope is reducing. Okay, so this is the final discussion for this question. So we have seen the input capacitor current and capacitor voltage, and what to speak of resistor current. It is not asked in the this discussion, but you can plot this also. Okay, so IR is something the value which is 0 initially, and after that it is reaching and increasing, and it is reaching to the final value, which is nothing but the 5 ampere. Okay, which is nothing but input current. At infinite it is equal to that. So do you think that it is a exponential or as a linear? Yes, it is exponential, because what is we are seeing here, the capacitor voltage following the exponential nature. So what is the IR actually? IR is nothing but capacitor voltage divided by resistor. So the capacitor voltage following the exponential nature. So the exponential nature divided by some constant is comes to be the exponential nature. Okay. So no need to confuse here. The capacitor along with the like means resistor current is also following the exponential nature, which is the complete fine assumption, not assumption, it is a complete fine analysis. Okay, so it is a 5 ampere, which is nothing but equal to I at the final state. It is IN. So we have seen all the plots here. This is my capacitor current, which is starting with the 5 by R, which is also called 5 ampere if my R is 1. Okay, and what is my capacitor voltage? Also is the resistor voltage, it also is the output voltage. VC is also the VR, is also my V out. It is nothing but the exponential reaching to the final value of 5R, which is here 5 volt, because R I am considering to be 1 ohm. Okay, so this is the sort of discussion regarding to that question. Okay, so anything that we can modify here in this circuit itself is, okay, yeah, one modification that we can do here is, and we can consider some sort of I mean to say pulse also. Okay, So let's consider the circuit with the pulse input. If the same circuit R, C, so I just consider R to be 1 ohm, need not to consider IC. This is my IR. So this is your I in. So here I am considering I in to be a pulse, 5 amp and 0. Okay, and this time is your T naught is your 0. So why I am considering T naught here? It is important to discuss. Okay, so what we have seen here, it is important the value of your I mean to say means T naught, because T naught with respect to RC is important here. Okay, if the T naught is much greater than RC, I'm not telling that RC is a time constant here. We'll see slowly that RC is a time constant here. But yes, of course, if time with respect to RC is fine, even I will say in general, if T naught is much greater than means some unit time, or T is much greater than the 0 sec, it means simply that we are giving much time to charge my capacitor. Okay, we are simply giving much time to charge my capacitor, so that the maximum amount of current can flow across the resistor after some time. Okay, so when we are giving much time to my capacitor, let's consider t equal to 0 positive. What is there? The circuit is having some 5 ampere step we are applying, and here in that case my capacitor voltage or the output voltage is nothing but the 0 volt. Okay, so this is also my output voltage at this instant. The discussion we already seen. So what is the IR here? IR here is nothing but a 0 ampere, because the voltage is 0, or V out is 0, because VC is nothing but a VR also. Here I should say VC equal to VR equal to V out. Okay, and I in equal to IC plus IR. Okay, so IR is 0. One more relation that we can write here: IR is VR by R, or VC by R, or V out by R. This is the one more relation that we can write here. These are the relation that are important here. Okay, yes. So what is the IC? All complete current is flowing through this capacitor only. So we have seen this thing. Okay, so the capacitor started charging, and what we have seen already in the previous discussion. And the capacitor is charging slowly. We are seeing that the amount of voltage is building across the resistor, so current in the resistor is building. Okay, so what will happen after t greater than 0? The amount of current across the resistor start building, so cap current start reducing. Hence, slope of VC start reducing. Hence, we can say output, or we can say capacitor voltage approach to some settled value that we have already seen, approaching to some value. Okay, so ideally, if I'm considering that my capacitor getting much time, where simply mean to say T naught is much greater than the 0 second, or to be much greater than the RC, then my capacitor getting much time to charge. Okay, so let's say somewhere here my capacitor voltage is this, so it is reaching to some sort of 5 volt here, or 5 R value here. Okay, let's say my T naught is somewhere here, which is much greater than this RC, because RC is a time constant for this capacitor here. We'll calculate it also for this circuit, the RC is time constant or not. Okay, so if T naught is much greater than the RC, also we can say T naught is much greater than the 4 or 5 RC, simply means 4 or 5 tau. Generally, we consider the settling time. Okay, so it means T naught is much greater than my capacitor completely settled. So for this case, what will happen? The every analysis is like that. Whatever we have considered. So yes, so my capacitor voltage, let's say, reach to 5 volt or 5 R till this T naught. And after that, what is happening? We have to see. This is my VC. Okay, so what is happening at t equal to t positive? T equal to t positive, what is happening there? We are removing our excitation. Simply means we are making the current to zero, means that is a open circuit. Okay, so simply what is happening? This is the open circuit. It is for, like, we are coming back from 5 ampere to 0 ampere. It means we are opening the circuit. R C. Okay. What we have seen till this point, my capacitor is already has stored the value, which is nothing but 5R. Okay. So what will happen now? There is a no circuit on from the source side, so it is simply a discharging circuit. The capacitor will start discharging. R C, V out also called the VC. This is my IC. So what will happen with the IC? IC is nothing but minus, because this was the direction, so it is nothing but minus 5R by the 5R is the voltage by R, so it is a minus 5 ampere. So what is the slope at T0 positive? Here is minus 5 by C. Okay, so the initial slope was also 5 by C. Initial slope was also 5 by C, and here the slope is also 5 by C. This slope is also, it is minus 5 by C. Okay, so what we are seeing, that capacitor will start discharging and it will discharge to 0, because after the T naught we have a lot of time to discharge the capacitor, because no other pulse or no other input excitation is applied after the T naught. Okay, so don't you think that this discussion is looking somehow similar to the discussion what we have done in the previous classes? Yes, that thing we'll see very soon. Okay, so what is happening here? I'm not going to much depth of this discussion, because already you have seen what is happening. The input excitation is open, and it is open forever. Means it is no current is applied forever after the T naught. So the output voltage is coming to 0. So if this is my capacitor voltage, and what to speak of capacitor current? Okay, so capacitor current will be what? Initially, what was this? It is 5 by, or why is it 5 ampere only? It was 5 ampere, and after that it reached to 0 in very soon, where T naught is much greater than, let's say this is a T naught, and after that what happened? It is minus 5. It is minus 5 amp. Okay, so again it is a lot of time to reach the steady state value. So this is the capacitor current simply. And what do you speak of the resistive current? This is my IC. What to speak of IR? IR is nothing but 5 minus IC, which is nothing but I in minus IC. So we can see, if we are subtracting the IC from the 5, then what will be the nature? Or we can directly see from our analysis viewpoint also. If my my capacitor current is 0, okay, initial my capacitor current is 0, and as my capacitor completely charged, sorry, initial my resistor current is 0, and my capacitor completely charged, it will reach to maximum value, which is nothing but 5 ampere. Means complete input current is flowing across the capacitor, sorry, across this resistor. Okay, so this is my instant T naught. So what is happening at T naught? When at T naught this is same, means till the T naught, what T means, capacitor is charged to 5 volts, so capacitor current is 5 by R. Okay, sorry, it is charged to 5R, so capacitor current, sorry, means resistor current is what? I should also write IR here. IR and T0 positive, what? My capacitor is charged to 5R by R, so it is nothing but 5 ampere. Okay, so it is a 5 ampere. What will happen? Slowly it will reach to 0, and if it will slowly reach to 0, means it is not changing direction. The resistor current is always in this direction. We have to be careful in that, because we have considered the resistor current in this direction, capacitor current in this direction. But after T0, when my excitation is removed or the current source is open, then what is happening? Capacitor current will change its direction, because capacitor voltage is built like this polarity. With that polarity, my resistor current is still in the same direction, which is nothing but V out by R or VR by R or VC by R. Okay, so the resistor current is not going to be change its direction, while the capacitor current will change its direction. So what it is? It is nothing but it will reach from this value to 0. So this is the thing. And also when we will subtract the IC, means from 5, you can see this thing. It is happening. It is coming this nature only. Or simply mean to say, if we inverse the IC first, or we can do one thing. First, make your you go from IC to minus IC, which simply means you fold this means or you flip the capacitor current across the x-axis, which is the time axis. And after that, what you can do, you can add the 5 ampere in it, or simply shift it by the 5 ampere up. What I mean to say, the my capacitor current was what? My capacitor current was 5. It was staying here, and after that this minus, and so this is my T. This is the capacitor current. And we can do one thing for finding the resistor current. What is the resistor current? Resistor current is nothing but minus IC plus 5 ampere, and this is nothing but 5 ampere point. Okay. So first, flip it across this x-axis. What is the time axis? When you flip now, it will like it will come like this. Okay. And when we will shift this thing with the okay, so okay, is anything missing? Minus IC. Yes, one thing is there, that after T, actually one thing is missing in this particular analysis. T greater than T naught, what is happening? My input is not present. So this particular plot will shift to, means it will be minus IC is already there, and this plot will shift with the plus 5 ampere, because my input excitation was present till this point, T naught. But after this, my input excitation is not there, so it is simply minus IC. Okay, minus IC plus 0. My input excitation not present. So what I mean to say, you can see that the plot of this minus IC till T naught will shift with till T naught. The plot till T naught will shift with the 5. You simply add the 5 and make it shift up. So make it shift up means it will reach to 5 ampere. And what to speak of the plot after this? This plot is no changed. It has no change. It has no change means simply whatever it is 5. After that 5 it will start reducing. So this will remain same. So this way we can also analyze the resistor current. It is a resistor current. Okay. So there are two sections. In this my input excitation is there, which is I in 5 ampere, and here my I in is 0, because the circuit is open or source is not applied after this instant. Okay, so simply we can see the resistor current derivation in this way also. Okay, so we have seen two things here, and one more analysis that is remained here for the pulse. Okay, pulse with the means periodic signal. Okay, that is, if I am applying, this is the third case of analysis. If this is my input current, which is nothing but a periodic signal, 0 t t by 2, 3 by 2, and so on. It is 5 ampere, and after that what is happening? This is my resistor, and this is cap. Okay. So this circuit we can analyze simply. What is happening? If okay, so here one case where that we were considering from the very starting, that capacitor or T naught is much greater than the RC. Okay, so point comes here whether RC is time constant or not. RC is time constant or not. We will calculate it. Okay. So before that, we will see here. You can also consider the cases here that my T is much greater than RC. T is much lesser than RC, and T is equal to RC. We can also consider these cases here. Okay. So what I mean to say, simply when we are considering the case one, which is T is much greater than the RC, then we are giving much time to charge my capacitor. And here we are giving very less time to charge my capacitor, and here it is equal. Okay, one thing. So before going into that, I should write the calculation for the time constant. So what the meaning of time constant? Simply when we calculate the time constant, let's say this is my input current, which is the independent source. It is the resistor. So there is a one resistor, one capacitor system is there. So let I open my capacitor, and I want to see the R equivalent across the capacitor. Okay. So what is the R equivalent? When we calculate the R equivalent, we make it open because of independent source. So only the thing that is visible to me across this cap, only R is there. Okay. So R equivalent is nothing but this R only. Okay. So the time constant tau is nothing but R times C. So this is the time constant of charging of my capacitor. Wherever we are seeing this exponential nature, so it has some time constant which is nothing but RC. So when we are considering that T is much greater than RC, or we simply can say T by 2, where we are removing the excitation, is much greater than the RC, simply means we are giving much time to charge my capacitor. Okay, so simply there is going to be no change in the like plot. Okay, so I will directly plot it by considering the first case, and you can consider the other cases. So let's say this is my input. T by 2 T 3 T by 2 2T. Okay. Oh, this is my input. Or input is 5 volt, or I should say it is yeah, 5 volt. Input is what I mean to say. Okay, there is no input actually. This is not input volt. Sorry, there is no input voltage. Actually, it is an input current. I should say 5 ampere. This is, and now I want to see the capacitor voltage. What will happen there? At time is much greater than the RC, it will charge to 5R value. This I call the 5R value. After it will discharge, remain here. Again it will charge, remain here. It will discharge, it will remain here. And after it will charge, it will remain here. Okay, so this nature we have seen already somewhere. Not a problem. Okay, and what to speak of the capacitor current? That thing we already seen. For one time we have seen till the T naught, but here we will see from for all different stamps of the periods, like this is T by 2, T, 3T by 2 and 2T. What is that? Initially it has some value of 5 amp because all capacitor current is all input current is passing through the capacitor, and after that we have seen it is reaching to 0. And at T by 2 we have removed the excitation, means capacitor is completely charging, and before that capacitor current will change its polarity and it will come here as minus 5 amp. This thing we all already seen. After that it will increase and it will reach to 0 again, and again it will change its polarity to, what do you mean to say? I will consider that capacitor complete discharge, means no capacitor current, and again my excitation is applied. Okay, so at T my excitation again applied, 5 ampere is again applied, and already we have seen the capacitor was completely discharged. So again the fresh cycle will start after the T. Okay. After T, a fresh charging of capacitor will start, where capacitor will change its value of current from 5 ampere, which is nothing but the maximum value of the input. Okay, so it is again started from 5 amp will reach to 0 slowly. Okay, so this value of 5 ampere again, and after that what will happen, it will again do the same thing whatever it was doing. So it will reach to -5 and go slowly this way. So this is the nature of my capacitor current. Okay, so this is your capacitor current. This value is your -5 and these values are your +5 ampere. Okay, so this is our capacitor volt, the capacitor current. And what to speak of resistive current, I have seen that it is nothing but -IC plus IN. But where my input is applied, okay, so it is nothing but it comes to be -IC plus 5 ampere and -IC plus 0 ampere. So where it is -IC plus 5 ampere, it is between the time instants from t greater than 0 and n plus 1 t by 2. Okay, and where this situation is happening from n plus 1 t by 2 to the time between, what I mean to say, 2n plus 1 t by 2. So let me check this thing. Okay, if we put n equal to 0, what I mean to say, for time between 0 to t by 2, my resistor current comes to be what? -IC plus 5. So simply means first flip the entire, I mean to say, resistive current, sorry, capacitor current across the x-axis that we have seen previous on the previous slide also. But what you can do, you can only add 5 in these means time windows. Okay, and because what is happening there, there is an input applied in these time windows from 0 to t by 2, from t to t by 2, and after that 2t to some other time value. Okay, but between t by 2 to t, input is not applied, so we cannot add 5 ampere here. We have to add the 0 ampere because no current is there. So if I put n equal to 0, and what will happen with the second equation? This is the first equation, that I call this first equation, that I call this second equation. So this is the result for the first equation. Now what to second equation? It is nothing but t by 2 to t, and it is okay, something is missing or not. So n equal to 2n plus 1 t. I think it is not correctly written. So n equal to 0 means t by 2 to, I have to see for the t. So for the t, what I can write in the best possible way, if n equal to 0, okay, n equal to 1, then what will happen? So I think I can write here n plus 1 t. Okay, better to write here n plus 1 t, or I can write here n plus 2 at t, or one more change I can do here. I just want to give you a generalized expression for the time, or I can write it as n plus 1 times t. Okay, so if I put n equal to 0, it will satisfy this. In this, what is happening? IR is what? Minus IC plus 0. Means you need not to shift this region. So with that particular thing, if I plot the IR, then what will happen? This is just a mathematical representation. You can do the analysis also. So in this region, okay, so in this region, what will happen? The capacitor current is inverted. It is my 5 ampere. Okay, so after that, what has happened? This region is not shifted, so it is to 0, and after that again it will increase to some value 5 ampere, and after that, okay, this is to 5 ampere, and it will again reach to 0, It will again increase. Okay, so this is the resistive current. It is not negative. We have seen already the resistor current is not negative. So it is happening. This is for t by 2. This is for t, 3t by 2, 2t, and so on. 0. Okay, so we have seen that resistor current is not going to change its direction. We already seen this step. Okay, so when my excitation is applied or not, the resistor current is not going to change the direction we have assumed from very starting. But the capacitor current will change its direction. That's why, okay, that's why we are seeing that capacitor current has positive and negative both values, while the resistor current has only the positive values. Okay, so this thing we can see. Okay, so anything else that is remained in the discussion? Yes, the remaining thing is that you have to analysis of IR without mathematical equations that I have written on the previous page, some sort of n values. Okay, and one more thing, you have to analyze for t much less than RC. Also, you have to analyze for t equal to RC. So these are all part of homework. Okay. So I think this is enough for the discussion with the current source. One more thing, the modification that is possible in this question, so that we need not to consider only the current source, we can change it to the voltage and resistor system also by just taking the Thevenin equivalent or the equivalent of this circuit. Okay, let I should tell that thing in the next video, and I will also try to cover the other cases remain, which is T is much lesser than RC. Whether it is a homework, but I can try. If there is a time, I will discuss about that also. So this is enough for the lecture number 8. Thank you.